Hi everyone, so this is my code for the last task, that is sign language classification. First of all, I have loaded all the necessary libraries and packages, and after that I have loaded a dataset. This is the MNIST sign language dataset, which is already present on Kaggle. This dataset contains 25 labels. As for the Z, we cannot represent Z in from only one picture. You have to move your hand for making the Z. So that's why this dataset only contains 25 alphabets, that is from A to Y. After loading the dataset, I have converted into NumPy arrays, and then I've created a list of class names. This can also be seen from here that I've only taken alphabets from A to Y, and then I've plotted a random image from a dataset with its real label, that is X. And after that, I've plotted data distribution. So from this, we can actually see whether the dataset is balanced or not. So as you can see, almost all the alphabets are from, I guess, 900 to 1300 in this range. So it is kind of a balanced dataset. So after plotting the distribution, I have then normalized my values and then converted my target column into one-hot encoding form. If you do not want to use one-hot encoding, then you can only do this step. And then in the later step, where I have used the loss function as categorical cross entropy, you will have to set this loss function to sparse categorical cross entropy. But if you have encoded your target variable, then you have to use this categorical cross entropy. So the model is created like this. I've used 3 convolution 2D layers, 3 max pooling 2D layers, and 3 dropout layers. You can check the different combination of these layers so that you can find the better accuracy according to your dataset. And then a flattened layer, and then 2 dense layers. And then after compiling the model with Adam Optimizer and accuracy as performance metrics, I have then fitted my model and trained my model for 10 epochs and set my batch size as 128. After 10 epochs, our training accuracy is 94.8% and our validation accuracy is 93.29%. And then I have plotted the training and validation accuracy and loss. As you can see from the plots, that's after this point, the model started to overfit. So for that, what you can do is you can set your dropout ratio to a different value and check that whether the results are changing or not. Or what you can do is you can use ensemble learning technique in which you can create different models and combine those models result, and then you can see whether it is giving a better accuracy or not. And then I predicted the class labels on test dataset, and then I have plotted a prediction with true and predicted labels. As you can see, this is I, so the true label was I and predicted label was also I, and the accuracy score is 93.29%. I can check it for another picture as well. So this is R, predicted and true matches. Let's check it for another. It's also predicting correct. Let's check it for another. So yeah, it performs quite well. After that, I've plotted a confusion matrix. This is used to summarize the overall performance of a classifier. It will tell us the true positive, true negative, false positive, and false negative of each and every class. But as there were 25 labels to predict, it is quite hard to understand. So what I've done is I've plotted the same thing in the form of bar plot. And it is clear from a bar plot that the class U was the most with misclassification here. And C, D, E, F, I, and many of the classes were almost predicted with 100% accuracy. So yeah, that's all. Thank you.